Module 8, Lesson 1 deals with the area of a parallelogram. Your suggested pacing for this one claims this is going to be a 2-day lesson, but I have my doubts because there's only 10 resources total in it. Let's see how quickly we can get through this because it is a pretty simple concept. The Dockland office, located in Hamburg, Germany, has a glass front in the shape of a parallelogram. Visitors can climb the staircase up the side of the building to the public viewing platform. Architects and builders constructed the building with very specific requirements to ensure optimal space and support for each floor. The height of the building is about 25 meters, and the length of the base is about 86 meters. If you can rearrange the parts of the parallelogram, how could you rearrange the pieces in order to find the area? Well, that's some of the stuff that we're going to be talking about doing in today's lesson. Before we get too deep into it, I want to show you something here on the web sketch. You can see that I have created a parallelogram that has a base of 1, 2, 3 units and a height of 1, 2 units. And I guess we should define a parallelogram. It is a quadrilateral in which opposite sides are going to be parallel and congruent. Now, if I was to show the area of this, you're going to see the area is going to be about 6 centimeters squared. But what if instead of a parallelogram like that, I had taken and created a rectangle? Now I have a base of 3 and a height of 2 again, and I show the area, and it is still going to be 6 centimeters squared. In fact, it does not matter how I divide this one up. As long as it has a base of 3 and a height of 2, it's always going to have the same exact area. If we were to take and come back here, something could do, if I was to take and cut a line right here through this little piece of the parallelogram and pick it up and move it and bloop, plop it down right there, what would I have? I'd have a rectangle. And that is why the formula for an area of a rectangle is also going to be the formula for the area of a parallelogram. And now we're going to get a proper definition for a parallelogram. A parallelogram is a quadrilateral with opposite sides that are parallel and have the same length. In other words, as I said, the opposite sides are parallel and congruent. Congruent means the same length. Let's watch this video on finding the area of a parallelogram.
A rectangle can be used to find the area of a parallelogram. Cut out the parallelogram. Use a straight edge to draw a right triangle on the left side of the parallelogram by using the vertical grid line that forms the third side of the triangle.
So they're doing what I showed you.
Cut off the right triangle and use tape to attach it to the right side of the parallelogram.
And they're taking that piece that they cut off.
This forms a rectangle. Because nothing was removed or added, the rectangle and the original parallelogram have the same area.
And they turned it into a rectangle.
Count the number of units along the base of the rectangle. The base is 10 units long.
So the formula for the area of a rectangle
then count the number of units up the side.
Of a parallelogram.
The height is 5 units. Multiply to find the area of the rectangle. So, because we know the area of the rectangle, we know the area of the original parallelogram is also 50 square units. Try another one. Cut out the parallelogram. Use a straight edge to draw a right triangle on the left side of the parallelogram by using the vertical grid line that forms the third side of the triangle. Cut off the right triangle and use tape to attach it to the right side of the parallelogram. Count the number of units along the base of the rectangle. The base is 12 units long. Then count the units up the side. The height is 8 units. Multiply to find the area of the rectangle. So, because we know the area of the rectangle, we know the area of the original parallelogram is also 96 square units.
Well, okay, that's pretty simple. I think you guys can handle it, and we're going to dig into it a little bit further before we just throw you to the wolves. The formula to find the area of a parallelogram uses base and height. And to identify these things, we're going to press a button here. Now, I should point out that base is going to be a vocabulary term you're going to see on your upcoming vocab quiz, and height is as well. The base is defined as any one of its sides. So generally speaking, the base is what it sits on, but depending on how you lay it out, technically any side could be the base. The height of the parallelogram is going to be perpendicular from the base and to its opposite side. So right here you can see you've got a base of B and a height perpendicular, it's a fancy way of saying it makes a right angle, of H right here. Now, a common mistake with the parallelograms is if they give you the distance of this diagonal, people will plug that in for the height. That's not the height, that's the length of the diagonal. The height is this distance right here that is perpendicular to the base. Now, to find the area of a parallelogram, we're going to have it listed in words. It is the product of the base and the height, and we use the formula area is equal to base times height. Now, you've probably seen that formula before when you were looking at the area of a rectangle, which also said area equals base times height, although I think the elementary school prefers using the area equals length times width version of the rectangle. They're both the same thing in the long run. Ramilla is painting a replica of the national flag of Trinidad and Tobago, I have no idea how to say that, for a research process. The area of the black parallelogram in the center, or find the area of the black parallelogram in the center of the flag. And you can see they give us a base of that parallelogram that is going to be 6 3/4 inches. And the height of that parallelogram, it's going to be the same as the height of the flag here, which is going to be 30 inches. So to solve this problem, we're going to start off with, let's see what they're going to do for us. So they want us to put in the base and the height here. So our base is going to be, what did we say right there? 6 3/4 inches. So I'm going to put in 6 fraction 3/4. And then the height we're going to recognize, that's just going to end up being 30. So we're going to take and type in our 30 and check it. That part checks. From here, we're going to go straight into the next stage where they give us the formula. Area is equal to base times height. And I'm going to tell you right now, I expect you to write the formula as the very first step on every single geometry problem you do. If you do not start off by writing the formula, I'm going to reject your homework. It's not because I'm being mean and ugly and just want to make you write more. It's because of rote memorization. Writing those formulas with each problem type will help you to memorize them. And it's really important for you to memorize these formulas. So from there, we're going to take and plug in what we know. We know the base was going to be 6 3/4 inches, and we know the height is going to be 30 inches. From there, we were going to take and multiply that out, and I'm going to use a distributive property to do that. So I'm going to get some clean real estate here, and we're going to use 6, hold on. We have it set up as area is going to be equal to 6 3/4 times 30, which means using my distributive property, I can break that down, and that's going to give me area is equal to 6 times 30 plus 3/4 times 30/1. From there, I could say the area is equal to 6 times 30, that's going to be 180, plus 3 times 30/1, that's going to end up giving me, simplify first, 2 goes into 4 2 times, 2 goes into 30 15 times, which means I'm going to get 15/2, which also is known as, bring our 180 down again, plus 7 1/2. Right there, 15/2 became 7/2, which gives me a final answer of 187 1/2. Now that's a good, easy way that you can multiply a whole number times a fraction without converting that fraction into an improper fraction. So we're going to take that and type in our answer, which is 187 fraction 1/2, accept, and check. I see my mistake here. I was talking and not paying attention to what I was doing. So this should have been a 45, and since that was a 45, we're going to erase some other stuff here. 45 divided by 2, that's going to end up becoming 22 and 1/2, and then 180 plus 22, that's going to end up giving me, whoop, need more eraser here, that's going to end up giving me 202 and 1/2. So jump back over to my problem, and let's try and put in the correct answer. So that should be 202, accept, and check, and now we're all good. For extra example 1, they give us a geometric puzzle composed of several interlocking geometric shapes. The dimensions of one of the pieces, a parallelogram, are indicated, and they want us to find the area of that piece. Now, hey, that looks like a goose. I have a goose. My goose loves me very much. Anyhow, we're going to take and get a picture of that goose. So we have our dimensions, and then we're going to go off to the side and we're going to do some serious grunt work to find out what the area of that goose is going to be. So we're going to break it out. I do believe that's a tangram they used to make that goose with. We're going to break it out, and we're going to start off by writing our formula. Formula is area is equal to base times height, where on this one, the base is actually going to be the 6. Area is going to be 6 times, and the height is going to be your 3.2. So from there, I can say area is equal to, and once again, you could use your distributive property to solve this, or you could work it the hard way. Using the distributive property, that would be 6 times 3 plus 6 times 0.2. That means area is going to equal to 18 plus 1.2, which means area is going to equal to 19.2. So the area of that parallelogram in the goose would be 19.2 centimeters squared. Come in right here, type our answer, and check. And it's that easy. Anybody can do this stuff. Now we're going to clear that out, and we're going to move on to example number 2. Now this problem is stepping up the game on you a little bit, because for this one, they give you the base and they give you the area, but they want you to find the height. And while that seems a little overwhelming, you already know how to do everything that we're doing for it. So the first thing we're going to do again is we're going to write down that formula. Actually, they say let's identify the giving values first. So what do we know? We know what the base is, and we know what the area is. And what do we need to find? We need to find the height, and that part checks. And then from there, we're going to find the missing length. Now you can see they started off by writing that formula, area is equal to base times height there. Then they're going to take and plug in the values that they know. So we're going to say that the area is going to be 45 inches squared, type in a 45, and the base, that's this distance here, also known as that distance there, is going to be 9. So we're going to plug that in and check it. That checks. And from there, we're just going to isolate the variable, just like we did when we were working with our one-step equations. That means that where we had times 9 right here, we're going to isolate the variable h by dividing 9 on both sides of the equal sign. 9 divided by 9 became 1. 1 times h became h. And 45 divided by 9, well, that's going to end up being 5. So our height is going to be 5 inches. And that is what showing your work is going to look like. You have to take and lay out your formula, plug in what you know in the formula, and then isolate your variable. It really is very simple, and you already know how to do everything that we're doing for that particular type of problem. With that said, now I want you guys to work on your final problem of this lesson, which is going to be extra example 2. Go ahead, pause the video, solve this one on your own. So, did you get the problem solved? Let's take a look at how I'm going to do it. We're going to start off getting a screenshot. So we have all of our pertinent information right here. Come over here, put it on a clean piece of real estate, and let's start working our problem. first thing we're going to do is write down the formula. The formula of a parallelogram is going to be area is equal to base times height. And this time, what did they give us? Well, they gave us the area. The area is going to be 48 is equal to, and they gave us the height right here. That height is going to be 6. So area is equal to base times 6. Now we're going to isolate our variable by dividing the base's friend on both sides. That, of course, is going to be 6. Divided on the right, divided on the left. 6 divided by 6 is 1. 1 times the base is the base. And then 48 divided by 6, well, that is going to end up being 7. Is it? Nope. No, it's not either. Not exactly 7. So let's take and plug in our answer. 6 goes into 48. How many times? It goes into a 7, leaving 42 left over. And then subtract that out. You're going to get 8 minus 2 is 6. Oh, gee, I am just totally losing my times tables today. Final answer is actually going to be 8. You never have one of those days when you know the answer, but you don't really know the answer. You know that you know the answer. Plug in right here. 8 is going to be it. Check our answer. The answer checks. Easy math. Now get started on your homework. Make sure you are giving me good, high-quality supporting work, and make sure that you are showing me your formula is the very first thing that you write in every problem of your homework. Good luck.